Hi everyone, my name's Brett Sherfy, and today I'm going to show you how to create a parabola in taxi geometry. Now, we usually think of a parabola as being a curved figure in geometry, and a parabola is actually defined as uh, a set of points that, given a fixed line and a fixed point, the fixed point being the focus, then a parabola is defined as the set of points that are equidistant from that line and the focus. And this will become more apparent as we go through the exercise. So, in taxigeometry, we would have to have the taxi circle tool. And I've gone ahead and added that tool to this document, and we can see that here. And if you don't have that tool, I'm sure there's tutorials on how you can create it or get it, but we're going to assume that you know how to either create or have that tool. So we'll start by creating a line, and if we hold down here on the line segment tool, we know that we can have a line. So creating a line, and I'll adjust this line to be dash just so that it's easier to see what I'm doing. And on this line, I'm going to create a segment. So I guess I'll create first 2 points, and these are just 2 arbitrary points. I'm just choosing them, and we'll call these points A and B. So I'll go ahead and label them. So now we have a segment on a line, and these points can be varied, so we can drag A and B, it can change, the length can change, and that's important to consider because we want our construction to be dynamic. So to begin this construction, I'm going to start by making a line, and this line will serve as our fixed line K. So as I mentioned earlier, the parabola is the set of points that are equidistant from the focus and a fixed line. Now I'm going to change the display of this line so it's easier to see, and we'll make this a solid line. And on this line I'm going to create a taxi circle, and the taxi circle is going to be constructed as a function of the segment that I created. So now you can see when I adjust this segment AB on this line, the taxi circle is created from that. That is, it's dependent on this line, this segment AB. And an important consideration in taxigeometry, since we only work in either the vertical or horizontal and not in the diagonal, is the slope of this line, this orange line that I've created. Now, if the absolute value of the slope of this line is less than 1, then the vertical distance will be shorter, and we'll want to create 2 parallel lines using the vertical distance. However, I'm going to adjust the slope of this line so that I know that it's greater than 1. And looking at that line, it's very obvious that the slope is greater than 1. So now this horizontal distance is shorter, because if I were to create a parallel line, and we'll see that, it would be up here where it actually hits it, and that distance is longer. So I'm going to go ahead and create 2 parallel lines. And I can actually select the second point. And I guess I have to select this orange line. And we'll have now 2 parallel lines. So we could see if I were to measure from the center of the circle up to where it would intersect, it's much greater than this distance horizontally. And if I were to adjust the slope, you can see here's where it's approaching 1, there is where it's 1, so the distance horizontally and vertically is the same. And now if I come here, this distance from the center vertically to where it intersects is actually shorter than this horizontal distance. And then that would change how it's constructed. So again, going back to a slope that's greater than 1. The next thing I want to do is create a second taxi circle. So again, I select my tool, I have taxi circle selected. And this does not have to be on your original line. You can just select it. But again, it's going to be dependent upon the segment that you created. So now that I have this second taxi circle, you can see that I can move it around. And it's not constrained to being held on any of these lines. Now what I want to do is when I create the parabola is going to be the set of intersection points where this taxi circle intersects this line and is equidistant from this line and this focus. So, and again, keep in mind that we're only going in the horizontal and vertical direction. So I can create intersection points by just clicking here. And as you move this circle around, you'll notice that there aren't just 2, but in fact there are more intersection points that I need to make. So now that I have these intersection points, I can use this intersection point and this point A, which can vary along this line, to create a locus. And a locus is simply all set of possible points that could occur at that intersection as a result of the segment AB changing in length. So I create my locus, and you can see that it's horizontal. And I'm going to go ahead and do that for the rest of, I have to deselect the line, again select this point and the intersection point, and point A, which is varying, again create a locus. So now I've created what appears to be somewhat of a parabola, but when I move it you can see it goes away. So again, I'm going to need to do the same thing for this intersection point. And similarly for this intersection point. So now we can see that as I move this taxi circle, it's dynamic. Now, one important consideration, as I mentioned earlier, is that this focus and the points that are shown here are equidistant. So it's important to consider that if I move this taxi circle to the other side, we can see that the intersections go away. So to make sure that this sketch and construction is dynamic, we have to do the same thing but on the opposite side. Because you can see as this distance approaches 0, or it gets closer, you can see they're getting closer and closer, and then as soon as you cross it, there's no longer a distance between this line, the center line, and this focus point. So it goes to 0 and it goes away. And then you can also see that you're losing these intersections. So doing the same thing here, I'm going to create these intersection points. There's again 4 of them. Oops. And now I'll create the locus again. So selecting the intersection point and the point that all of these can vary by. And finally, this last intersection point here. So now this construction is dynamic. So as I move this taxi circle, you can see that it works on both sides, so that this focus point is equidistant, so the parabola is showing all points that are equidistant from this line, this fixed line, as well as this focus here. And as you move it, it's dynamic. So that's an important consideration to ensure that your construction is robust. So you've now learned how to create a parabola in the taxi geometry, and I hope you enjoyed this lesson. Thanks.